Hello, this is Mr. Stansbury. I'm going to take you through the problem-solving notes in the similar figures unit. Okay. At the end of this, you should be able to say, I can use the properties of similar figures to solve real-world type problems. Okay, so let's take a look at an example. Example 5. Emmett is lying on the ground. He looks up and notices his friend Unikitty's head lines up with the top of the tricycle behind her. If Unikitty is 6 centimeters tall, Emmett is 8 centimeters from Unikitty, and 40 centimeters from the tricycle. How tall is the tricycle? So probably 80 to 90% of the battle on this here is just going to be setting up something to represent this problem here. So let's do that. Let's start drawing ourselves a nice little picture here. So let's do this. Here is, let's say, Emmett is sitting here. Right? So there's Emmett laying on the ground. And it says that his Unikitty is 6 centimeters tall, and Emmett is 8 centimeters from Unikitty. So let's do this. Let's say that is 8 centimeters. So here's where Unikitty is standing. And we know that Unikitty is, it says 6 centimeters tall, right? 6 centimeters. So that's the top of Unikitty. Excuse me. And then it says Emmett looks, let's see, and notice that from where he's sitting, the top of Unikitty lines up with the top of the tricycle, which happens to be 40 centimeters away, right? So let's do, I don't know if I can make that there. Let's do that. Okay, so here's the tricycle, right? And we know that this here, Emmett is going to be able to look, and right up at the top of Unikitty is where the tricycle, top of the tricycle is going to be at. Okay, so that's a little off, but you get the idea. Okay, so that's a right angle. That's a right angle. We know that from here to here, all the way over to there, is 40 centimeters. And this is the, again, this is the tricycle here. Okay. How tall is the tricycle? So this is what we'd be looking for, right? Okay, now just for a little bit of fun, I actually went through and drew this same figure out with a little bit of help from the internet and get some pictures of all these things. So same thing that we just had set up. Now we're just going to try to figure out what this is here. So hopefully we can look at this and say this triangle here, let's call this E, U for Unikitty, T for the bottom of the tricycle. Let's see, that's just by default, I guess, A and B. So we should hopefully know that, notice that EAB, so we got, oops, let's try that again. E to A, whoa, not what I was trying to do there. E to A to U, sorry. E, A, U has to be similar to, I'm not going to draw it quite to scale because we don't have enough room. Is going to have the same, it's going to be similar triangle to E, B, T, right? Because that is the same as that, and then obviously E has to be the same as this E, so then these have to be the same as well. So since we know that they have to be similar triangles, we've shown right there that they have to be similar triangles. So we know that this side here is 8, this side is 6. We know that this whole side down here is 40, and this is X. So now we can set up our ratio, right? So I'm going to say, let's say the bottom sides, 8 is to 40, as the right sides here, 6 is to X. Cross multiply, and away we go. Right, so we get 8x is going to equal 6 times 40 is 240. So we just divide both sides by 8. And we get that the tricycle has to be, let's see, 240 divided by 8. Uh-oh, yeah, I got it. Is 30. So we know that the tricycle is 30, in this case, centimeters tall. Okay? Okay, so that's really all there is to this one here. Again, the big thing is trying to get it set up. You got to try to draw yourself a picture that represents it, and just take your time with that to make sure that you get everything all correct. Okay, so that's all there is here for problem solving. If you have any further questions, please feel free to ask in class. Thanks.